Thank you. Hello, everyone. My name is Florina Muntenescu, and I'm a developer advocate at Google. So today, I want to tell you about migrating to the paging library. But before we get started with what the paging library is and what the components are, I want to tell you first about the architecture expectations that the paging library has. So when we're talking about handling lists and in general with handling data, we will probably work with a repository. And that repository would work with a database and with a backend. So probably if you're using Room, your DAO would look something like this. You would return a live data of a list of user. Then that repository would also expose a live data of a list of user. Then that repository would probably be used by a view model that would as well expose a live data of a list of users. And then in the UI, you would work with that view model, you would observe the changes in the live data, and then you would populate a list adapter. So in the end, the architecture that is expected here is to have this stream of data coming from the data layer. But even more, we also expect you to work with, or the easiest way to get started with paging is by working with a list adapter. So I think a list adapter is actually a sort of a, let's say, key in migrating to paging. Because it has some elements that I think are really important also in making sure that your architecture is good. So first of all, the list adapter takes an immutable list. So this means that in this adapter, you won't handle the list at all. You won't be making any changes. And then also, the list adapter provides animated updates. It makes sure that the diff is computed on the background thread. And actually, the list adapter has been around for quite a while. It was released in support library 27.1. So I can't see you very well, but can the folks that already use list adapter in their apps raise their hands? Okay, so that's maybe less than half. So I'm going to go over list adapter a little bit just to make sure that we're all on the same page on what this means. So in the list adapter, you would submit a list. Once the list is submitted, then the RecyclerView displays that list. But when you're submitting an updated version of that list, the list adapter will make sure that the transition to the new list is nicely done with nice animations, and that all of this diff between the old and the new list is done on the background thread. So let's see how our UI will look like, how our code would look like. So in your activity, you would use a list adapter, and then you're listening to changes in the live data, and you would submit the list. But then, how does the list adapter look like? So it's very similar to the RecyclerView.Adapter. So you would pass in a user, so the model that you need to display for the data, and the view holder for that specific model. If you're displaying multiple types of data there, I would say just pass, instead of the user, you would pass maybe the super type for that model, and then instead of the user view holder, just pass a view holder. And the rest is actually very similar to working with a RecyclerView.Adapter, except for the fact that you're not holding the list, you're not working directly with it. What's different also is that you need to implement an item callback. So practically the adapter needs to make a difference between the old and the new list. And in order to do this, it needs to know how to compare the items. So essentially in this callback, you're telling the adapter how to tell whether two items are the same and whether two contents or the contents of the items are the same. And then in the bind view holder, you would just get the item, and you would get non-nullable result back, and you would bind it as usual. So for me, the key and the hardest part, actually, when migrating to the list adapter, is actually making this change to immutable list. So I actually tried to do this in Plaid, in one of the sample apps that I'm working on, and actually I found that making this change was the one that, it wasn't difficult, but was the one that's most time-consuming. So before there, for example, in my recycler view, I was working with the data. I was filtering it and removing or adding items to the collection that was held by the RecyclerView.Adapter. And this is something that the list adapter really avoids by the fact that it's using this immutable list. And in general, regardless of whether you're using paging or not, I think moving to the list adapter is one of the best decisions that you can make for your UI. Okay, but in order to actually discuss about paging, let's see a little bit what would be the problems that the paging needs to solve. So what are some of the challenges that we encounter when we're working with lists? So I was saying that our UI would work with a view model. For the sake of simplicity, let's say that the view model works with the database where data is stored, and then we would also work with the backend where we're also retrieving data. But what's important to remember is that we want to show updates to the list. We want the list that is displayed on the screen to actually be the latest one that we have stored. So this means that in our database, or from our database, we would expose something like a live data or an observable, depending on what you're using, live data or RxJava. So what happens then? What would be the flow for us? From the backend, we get some new items. We save those items in the database. But because in our case we're interested in all of the content, all of the contacts, this means that the database, live data or observable will emit the entire list. So then this list is passed to the view model. Then the view model passes this to the activity, and then the adapter nicely animates the changes, and our new items are added. But this sounds nice, but in reality, things are actually a bit more complicated. If we're only looking at the database, we're saying that we want to get, let's say, all the contacts that we have. But what if we have 10,000 contacts, 100,000 contacts? Well, it means that this list would be quite big. But do we actually need all of this list when our user is only able to see, I don't know, 20, 30 maximum, let's say, items on the screen? Probably not. So I think this is the main challenge when working with lists, handling large data sets. But then when we're working with lists, I already mentioned all of these layers. We have to work with lists on the backend. When we're doing the request, we have to save them. We have to work with them in the view model. So this means that we end up applying a lot of logic, maybe even a lot of several times if we have multiple lists in our app. Next, working with lists can be, let's say, quite a long-running task. So we need to make sure that whatever operations we're doing, all of these operations are done on the background thread. I won't go over the usual 16 milliseconds importance and so on. But making sure that we're not blocking the UI is important. Next, we want to be lifecycle aware, because we should only request more data from the database or the backend if the user is actually looking at a screen that has a list. If our application is in the background or there's another activity opened, we need to make sure that our lists are lifecycle aware, that we're not requesting too many things. And next, we want to make sure that we're flexible. We want a library or a solution for handling pagings, for handling list UIs that applies to different ways of getting the data, of handling the data. So the library that's aimed at solving all of these challenges is the paging library. So let's go over its components. So the main component of the paging library is the page list. It's the one that actually holds the data. And the page list is backed by a data source. And this is the one that helps us page the items and get the items. So you can say that the data source holds like a bigger snapshot of the data, and then it adds data to the page list as data is needed, as the user scrolls. So what does that mean? What are the changes that we would need to make in order to start using paging? Well, instead of having a live data of a list of users, in the view model, we would change this and use a live data of a page list. But then, what do we do with the DAO? What do we do with the data from room? Well, instead of having a live data of a list of users, you would say that we can have a live data of a page list. Things are actually not this simple, and here's why. When we need to display a list of data, how are we displaying it? How are we requesting the data? How are we defining the pages, the amount of content that we want to retrieve from the database? Do we put smaller pages? Do we use larger pages? In the end, all of this depends on the data that we need to display. If we're displaying larger items, it means that the size of the pages can be smaller. If our items are smaller, then it means that we can request more items in a page. So all of this would be done via the data source. So more precisely, the data source will know which data to get the items from 6 to 12, for example. And then would work with it, would put the data in the page list. But in order to construct a data source, we would use a data source factory. So this means that in our DAO, instead of working directly with a page list, we would actually work with a data source factory, where the int is a key, and then the user is the actual object that we want to retrieve from the database. Then in our view model, we would, when we're creating the view model, we would get the factory from the DAO, and then we would create the page list by using the live page list builder. And here, we're passing in the constructor the factory, but also the number of items that we want to have in a page. In this case, would be 30. Then in our activities, instead of a list adapter, we would work with a page list adapter. And then in our adapter implementation, instead of a list adapter, we would switch to a page list adapter. In the end, the page list adapter is actually just an implementation, an extension of the list adapter that also knows how to work with the page list. Also, we would need to define the item callback exactly in the same way as we did with the list adapter. And then in the bind view holder, we have a small change. So initially, if you're working with a list adapter, you would get a non-nullable object. But when you're working with a page list adapter, you would get a nullable object. And I'll tell you soon why. But first, let's talk a little bit about the live page list builder. So you would construct a live page list builder by using the data source factory and the page items. But sometimes you might actually want to configure something more. There are other things that we allow for configuration. So for this, you would use a page list config builder, where you can set things like the page size that we talked about earlier, but also other things like the initial load hint, the initial load size hint. So this is the amount of data that needs to be retrieved the first time when the list is initiated. So when you're thinking of how to define this item, think that when the list is first displayed on the screen, you want to avoid that the user, like at the first scroll, already needs to request more data. So this is why the paging library sets as default as a load size hint, the page size times 3. So this means that there won't be, the user needs to scroll a little bit more until the data is more requested from the data source. Next, we can set the prefetch distance. So how far from the end of the list do we need to be to start requesting some data? And by default, this is the page size. And then the final setting that we have is whether we should enable placeholders or not. So let's see what placeholders mean. So let's say that for now we set placeholders to be false. Let's see what happens with our list. So our data is retrieved, the list is displayed. You see that the scroll bar there is quite big. We're scrolling until the end of the list. We get to the end of the list. Maybe we display a spinner, maybe we stopped abruptly. We'll see. And then at that time, we're requesting, or more data is retrieved from the data source. Once the data is received, you see that the scroll bar size has already changed because we got more data. And then we can scroll again and so on. So this means that your list will hit that end quite suddenly. The scroll will change. But if you enable placeholders, which is also the default, here's what happens. From the beginning, your scroll bar will actually have the right size, because actually all of the items will be present, just that the items that haven't been yet retrieved from the data source would be null. So this means that that's the place where you're able to handle that nullability and display some placeholders until the user actually gets to see those items, and then those items get to be retrieved from the data source. So for placeholders, there are advantages and disadvantages. There are areas where you can and areas where you shouldn't use them. So the good thing is that if you use placeholders, the user can scroll past what's loaded. So this means that you can very nicely use it with fast scroll. If you have something like context, you can easily jump to a certain letter, and we don't need to load absolutely all of the items until that letter. The scroll bar looks correctly from the beginning. And then also you don't need to implement that loading spinner and create all of that extra logic, because you already have the entire content of the list there. The negatives is that, well, the items should be the same size, because if the items are different size, like, for example, at the social feed, then you'll end up with some maybe strange animations when, from the placeholders, the item needs to get smaller or bigger, and it won't look that right. Also, you need to implement handling of null items in your adapter. But most of all, the data source needs to count the items, because based on that, it knows how many items it should return. And not all data sources are countable. So if you're working with data from the database, Room will know how to count these items. But if your data comes from the network, maybe your response doesn't tell you how many items to expect. OK, so I talked about the live data, live page list builder. But what if you're using RxJava? Well, we haven't forgotten about you. We have an Rx page list builder. So instead of using a live data, you can use an observable by just building a Rx page list builder. The same, you would pass the factory, you'd pass the configuration. But instead of calling build, you would say build observable. But you can also use build flowable, which of course would return a flowable of a paged list. OK, let's see what's actually going on under the hood, because that will help us understand better which data sources we should build. So in the repository, we would work with a live page list builder, and we would call this build method. So when this is triggered, then the live data of a page list is created. But only when we have an observer to that live data of a page list, we are creating the data source based on the data source factory. And then from the data source, we are requesting the initial data based on that initial setup that I mentioned before. Then both the data and the data source are held in a page list. This page list is then passed via the view model to the UI. In the UI, we're submitting the list to the page list adapter. And then once the page list adapter has a reference to the list, it can display it. As we're scrolling it, let's say that here we have the placeholders enabled. Once we go to items that need to be loaded, the page list just requests the data source to load the next page. The data source loads the page, puts it in the page list, and then the items are displayed. But if something in our data source changes, so for example, if we're adding new items in our database, it means that the data source is no longer valid. So the invalidate method is triggered. So what does this mean? So let's say that an item was added in our data source in Room. So an invalidation will trigger a recreation of the page list. So we'll trigger a recreation of the data source. Then again, we're requesting the initial data. We're putting it in the page list. Just that the difference is that this time, that initial data that is being requested is the one that's being displayed right now. We're not requesting the entire data until whatever the user scrolled. We make sure that we only build a page list with the data that is needed for the user. So we're passing this to the UI. We're submitting the list. And then the adapter will make the diff asynchronously. And then we'll see what changed. And then it will update the UI by adding the item that was added in the database. So actually, under the hood, the page, the list, looks like a live data of a list. You would construct it, and you would configure it in the repository. And then the adapter will be the one that handles new page list and internal updates. OK, let's see what kind of data sources we have. So we have 3 types: positional data source, item keyed data source, and paged keyed data source. So let's start with positional data source. So for me, the easiest example for positional data source is having something like contacts, where you're able to scroll to different elements. So we would need to create a data source that extends from positional data source of the item type. OK, let's see what will happen with our page list. So we would work with a positional data source. So let's say that the list that we have there is the entire list that we have in the database. Initially, what we're doing is we're calling load initial, where we need to pass what is the start position. So probably in our case, because it's the first time we're displaying this, it would be 0. We're setting the page size, what is the load size, and whether the placeholders are enabled or not. So let's say that we are enabling the placeholders. The response that we get back is the data, the position, but also the total item count, because we have the placeholders. OK, once the user scrolls, we get to the end of the list that we have displayed. So then the load range method is called. So here, we need to pass the start position and the load size. The next set of data will be retrieved from the data source and then put in the page list. And then, because we have placeholders, it means that we can scroll lower past items that weren't loaded. So we're at a different position. So now load range is called again. So then we will get the position from the recycler view and use that as a start position. And we would pass the load size. We would get the data back. And we're only displaying the data that is needed, the data that the user actually had seen. What was added actually in the paging library 2.1 is the page drop. So this means that after a while, if we end up holding way too many items in memory, so like those items that aren't seen, the paging library allows dropping those pages. So we're not holding way too many things in memory. OK, but getting back to our positional data source, let's say that the data gets invalidated. What happens in this case? Well, I said that another data source is created. Here, load initial is called again, with the start position being a bit above of the item that is being displayed right now, together with the page size and so on. Then the data is being retrieved from the data source, and then a new page list is created. With the help of the page list adapter, the diff is computed, and now we're displaying the new items. OK, next data source is item keyed data source. So let's say that we have a list like this of, let's say, names coming from the server. What's important with the item key data source is that a certain item can tell us how to get the items before it or after it. For example, it's easy, once we have Ruby, we know how to fetch the items before Ruby, because these are all ordered alphabetically. Similarly, if you want to get the items after Sandy, we know that that can be a key to be used to retrieve the items after it. So this means that in our data source, we would implement an item keyed data source based on the string. Here, the string is the key that we're using, but it can be whatever you need. And then the item that we need to return. So what happens with our page list? So we have the item key, the data source, and the backed list. The load initial, of course, changes because what we have is the key. So we need to load the initial data based on the initial key that we define. Then we have to set the load size and whether the placeholders are enabled or not. So here, let's say that the placeholders are not enabled. We get the data back, and then we're displaying the list. Once we're scrolling and we're at the end of the list that we have in memory, the load after method is being called. And there, we can pass the key as the key of the last item that's being displayed. Based on that, we can get the items after that key, and then set them to the page list, and so on. And then we can continue loading after. If the data is invalidated, here's what happens. So we're loading in initial with the requested initial key because we know what what's the item displayed. And then we just get that data and we display it. If we're trying to scroll up, because we have the key, then the load before method is going to be called with that key being passed. And then the items before the ones displayed are retrieved and then set to the page list. Then the third data source is the paged keyed data source. So this is actually how a lot of the backend out there work. So if, for example, you're using the GitHub or the Reddit APIs, you see that if you're searching for a query, then the response that you get from that backend is of results, but also with the next and the previous page of those results. So you can see this as a sort of a linked list that has links to the next or to the previous items. So we would implement a data source by extending from page keyed data source, similarly with a key and with an item. So what happens in this case? So our pages will have links to the next and the previous. So when we load initial, we say what's the initial load size and whether placeholders are enabled or not. So then we get the first bunch of data. But here we also get the key to the previous page and to the next page. And this is set in the page list. Once the user scrolls, the load after is being called. And here, based on the key to the next page, we are retrieving the data from the data source. What we're getting back is the data, but also the adjacent page key. And that is then set to the page list. What happens when we invalidate? Actually, this is the difference between this data source and the other data sources. When we're invalidating, a new data source is created, but then the load initial is being called. But here, we actually don't have an initial key. So what we do is actually load that first bunch of initial items where we're getting the next and the previous page keys, and these are displayed. But actually, this is not really a problem because this is something that would happen when you're doing, for example, pull to refresh. So this means that you're already at the top of the items. So the fact that you're requesting the initial items is actually all right. OK. We talked about data sources, but we didn't really look at what happens when you need to get the data from the database and the network. So the thing is that they work great together. It means that you are able to page the backend with all the benefits from a local cache. You're able to support offline cases. You're able to easily resume your application. And you're minimizing the network traffic. Well, let's see how this can be implemented. So I said that the view model would work with a repository. And the repository would be the one that decides when and how to get the data. So one way to decide when to get the data from the network is by using is the network, are we connected to a network, yes or no? If we are connected to a network, then we're getting the data from repository. If we're not, then we're getting the data from the database. But, and then once we get the data from the network, then we store that in the database. But we saw that actually with this kind of data switching, there are several problems. So the first one is that actually this connecting state is a very oversimplifying of the problem. What happens if some of your requests succeed, but some fail? How will your data actually look? Then you are storing some data in the local database, but you're not really using it at all, even if it's present. And then we thought about a different solution. So having the database as the main source of truth for your data. And only when we are out of data to request the data from the network. And then store the result in the database and emit a new live data based on it, a new list in live data. So this means that we have a consistent data presentation. We're just getting the data from the database. It's a simple process. We need more, we load more. And then also, it allows us to easier create mechanisms to handle data failures. If we're out of data, we can just get data. If we couldn't get the data, then we know we can decide what to do, when to retry, and so on. And then, optionally, we can say that whenever we are observing a live data, we can also trigger a refresh to the network. So it gives us this extra flexibility. So what does that mean? What are our needs in terms of the paging library? It means that we need an out-of-data signal from the database to know that, hey, I'm out of data. You need to load some more. So this means that we also need to trigger network loads to be saved in the database. So to do this, to have this signal of I'm out of data, load some more data, the paging library came up with the boundary callback. So in this class, you would work with the service, so with your backend, and with the database. And you would implement the page list boundary callback. So here, there are two methods that you need to implement. One is on item at end loaded. And here, once we're at the end of the database, of the data from the database, then we know that we can request more data from our service. And then, based on the whatever elements that we have from the service. And then once we got the response from the backend, it means that we can switch to the IO thread and then save that response to the database. And then automatically that database will emit a new live data informing your UI of the changes. There's a small trick here, because on item at end loaded can be called multiple times. So I would suggest adding a isLoading flag just to make sure that this method isn't called way too many times. OK, so how do you set this boundary callback? How do you make the connections? Well, in the live page list builder, you just set the boundary callback. That's all. It means that you can implement your boundary callback in a separate class and just set it when you're creating it in the repository. So overall, the paging library gives us a lot of things. It allows us to page data from the database, from the network, or both, and display that data in a recycler view. It's actually an extension of the observable list pattern, so having a list, live data of a list. Next, it allows us to configure the load size, the prefetch, whether we want to have placeholders or not, and so on. And then it also integrates with Room, with live data, and RxJava. So if you want to migrate to the paging library, so to the page adapter, I would say that the first step that you need to make is to make sure that you've migrated to the list adapter. Afterwards, the changes that you need to do are actually quite minimal. Thank you.